Welcome to this video on describing quantitative data with numbers. By the end of this video, you should be able to calculate the measures of center such as mean and median for a distribution of quantitative data. You should be able to calculate and interpret measures of variability such as range, standard deviation, and IQR for a distribution of quantitative data. And you should be able to explain how outliers and skewness affect measures of center and variability. Here is the data that we're going to use for this activity. First thing I want you to do is to calculate the mean and the median for the set of data. Remember, to find the median, you have to put the data values in order to find the exact middle. The mean is the average. Add up all the numbers and divide by the total of numbers. And then write a sentence how they compare to each other. When I calculated this, I got the mean of 5. So I have this symbol here. It's an X with a bar over it. It's called X bar. And it's the symbol for mean. So I got 5 for the mean and I got 5 for the median. So the mean and median are exactly the same. What is the range of the data? Remember, range is max minus min. The maximum is 8. The minimum is 3. So you have a range of 5. So finding range can be helpful, but it doesn't tell us how spread out the data is between the minimum and maximum. I want to know the average distance of the values from the mean. I want to know the average distance away. I don't want to know how far is it from the top number to the lowest number. I want to know the average distance from the mean. So that's what we are going to do today. I want you to complete the table. We're going to take each data point. Okay. Then the distance from the mean. So it's the data point minus the mean, and you're going to square that number, so 0 squared is 0, and you're going to follow the same process for all of these. All right, here's the table filled out for you. Each data value minus the mean, square their difference, and I come up with a distance from the mean squared of 2.5. Part B over here asks the average you calculated is the average of the squared distances from the mean. How do we use this to find the average distance from the mean? What do you think we need to do to find the average distance from the mean? Since this number was made up of the squared numbers, we're going to take that number and we'll square root it. And we'll get 1.58. What I'd like you to do now is go to Stapplet.com. You can use the QR reader, go to the one quantitative variable single group, put in your data, and look at the summary statistics and verify our work. How do they compare? So after I've gone into Stapplet, I found that our standard deviation at 1.58 is smaller than Stapplet's standard deviation at 1.69. Why is that? I wonder. So I'm going to bring us around to the formula for our standard deviation. These numbers are a sample. They're not the population of all the number of colleges applied to by individuals. So whenever you are finding the standard deviation of a sample, you need to divide by n minus 1, not n being the number of terms. Okay, so that's why the numbers are different. The standard deviation formula for a sample, this is on your formula sheet, okay? You're going to take the sum. That's a sigma, it means sum. The sum of each term minus the mean divided by 1 less than the sample size, okay? This is the official formula for standard deviation. You'll be happy to know we do this in the calculator. You're not going to be doing this hand table again. It's just to kind of help you understand how we got there. Now, the next thing I want you to do is I want you to go back to Stapplet and include my information. It says I applied for 20 colleges. So go back to Stapplet and do the edit inputs and add 20 onto the end of the list and calculate the new median, new mean, and new standard deviation, and how do they compare to the original measures, and why do you think that? All right, so for the new mean, I got 6.67, standard deviation 5.244, and the median is still 5. So the new mean and standard deviation increased from the original values and the median stayed the same. The outlier, or we could probably have put possible outlier out there because we haven't verified, increased the sum of values, which increases both mean and standard deviation. So what I want you to take away from this is something about resistance. Mean and standard deviation are non-resistant. Non-resistant to the pull of an outlier. Okay. What that means is that outlier, my 20 college applications, pulled the mean and standard deviation, but the median wasn't really affected because the median is the middle. The middle number didn't move that far by adding just one more value on the end. Okay, so mean and standard deviation are non-resistant. Median is resistant to the pull of an outlier. All right. Mean and standard deviation, not resistant. Median is resistant. All right, there are 3 big takeaways I want you to take out of this lesson. At the beginning, I said these are things that you should know. Here's the information that lets you know that you did get them. All right, here we go in the first. All right, so the mean is the sum of data values divided by the number of data values. And we want to use that with symmetric data. That means if our distribution has this nice symmetrical curve to it, where it's about the same on both sides from the middle line, that's when you want to talk about mean. Okay? Median you want to use with skewed data. Median is the middle point of your distribution. So if you have a left skewed or you have a right skewed, you want to talk about the median if you want to refer to the center. Remember, the skewing goes where the tail is. If it's on the left, that means that's a left scale. If the tail is on the right, it's a right skew. The next thing we want to discuss is variability. Variability, there's different things you can talk about variability. There's range, which is your max minus your min. Remember, that's a one number, not an interval. Don't tell me what the smallest number and the biggest number is. I want to know what the difference between them is. Okay. Standard deviation is also a measure of variability. Standard deviation, you're going to take the square root of the sum of each data value minus the mean, square that, divide by n minus 1. Okay? How to interpret. Interpret means explain. We can't just put an answer down. We have to explain what the number means. So I have a math lib, remember, for you to help you with this. This is set up in a way that the AP readers are looking for. It's clear and it's concise, so it's a good way to interpret. Okay? So the blank typically varies by blank from the meaning of blank. That doesn't mean anything yet. But the context, and when I say context, I mean what is the topic of the question? Down below, when you do your check your understanding in just a couple minutes, the context of the problem is pumpkin weights. So you'd say the pumpkin weight typically varies, okay, by the standard deviation, whatever the standard deviation is, with some units, whatever the unit of measure is for the standard deviation. So in our pumpkins down here it says pounds. So whatever the standard deviation number is, pounds, from the mean of whatever the mean is and its unit. Okay? So it's kind of a plug in the blank. The last thing that we want to talk about is resistance. Resistance. The mean and standard deviation are greatly affected by outliers. That means they are non-resistant. They get pulled way off from where they would be if the outlier wasn't there. They can't help it but to move. So they're non-resistant. The median and the IQR are not greatly affected by outliers, therefore they're resistant. They're able to resist the pull and stay essentially where they began. They may not stay in the exact same spot, but they're still very close to where they were. We haven't talked about IQR yet, but we will. So I just wanted to plant that there for now. If your data is skewed and you want to talk about the center and the variability, you should use median and IQR. If the data is symmetrical and you want to talk about the center and the variability, you need to use mean and standard deviation. Your next step is to finish the check your understanding and turn it in.